Hello, this is part 2 of learntris in red. So in my last episode, I made it this far. We've got all the first 15 tests done, all the way up through making the different shapes. And I believe the next step, if we type over here and type Tanko next, I guess I should check that I'm checked everything in, get remote. Everything's at tangent stream redtris on GitHub. And we say Tanko next. And it gets us the next operation that we need to implement, which is over here. Well, didn't quite work, did it? I'm working on that. We got to get this cleaned up a little bit. But anyway, so the these are all single character commands, and the right parentheses command rotates the active tetramino 90 degrees clockwise. And here we see the I tetramino rotating clockwise within its bounding box. So if we say we generate the I tetramino, we rotate it, print it with the lowercase t, and then quit, then it should print out these different rotations of the thing. So that's my mission for today. And if we look over here, this is what the red code that we have so far. It's only about 74 lines, and most of them with a lot of blank spaces. And we need to rotate. So you can implement rotation a couple different ways, but I am now fond of using the reverse and then transpose method. And I think reverse is covered, but there, as far as I know, is no transpose. So let's see what we can do in red to ameliorate that. So need that anymore? Just some red console. I'm just going to start a new one. Let's actually go to that directory, though. cdd ver redtris. And we'll say red. And then we'll say do load. So first we're going to load it, then we're going to do it. And the thing we're going to do is redtris.red. That goes into an infinite loop. We hit Control C and break, and then we have all these definitions in memory. So we should be able to say T. I bet if we say commands I. Oh. Maybe we have to quote that. Invalid word I. That's interesting because it does seem to. Not sure what to make of that. Maybe we say two words. Say like this. We have to quote it, right? There we go. Okay. I'm still learning this language. All right, so then we have to do that. Right, and there we have that's the result of doing the the I command, which already works. And then if we did T, I don't think you have to do anything for a simple symbol like T. You don't have to do anything, but when it has the caret in front of it, it seems to do something. All right, so we want to rotate that. So that's actually called tet, and we can see that it's it's a grid put tet is what we say. Grid put tet, and then we can see the version of it. All right, so we're going to rotate this, and that would be a transpose. So I think what I can do, I think there's a word called take, removes and returns one element. So I think if we say, all right, so we'll say, I'm going to say new, right, is going to be a block. And I just want to say append to make sure I know how to do that. So append, so we say question mark append. So we say append a series of values. So append new 1, and then new should be 1, right? Okay, so new is going to be this. How about we put it all in one line? New is this, and then for each row of tet, we're going to collect something. We're going to collect we don't have to, because we're going to append it directly to new, right? Oh, maybe we could do it that way. We don't even have to say no. We can do collect there. So first of all, it's for each. We say collect each row of tet, keep, take, row. Yes. And if I do this again, it's hard to tell, yeah, but that was 4 of them. So if I do that 4 times, then I will get the transpose of that. And now tet is now empty, but we're going to just like destroy it, right? So we're going to say let's do it again. New. Oh, how about what's the size of the tet? The tet is always square, but they're not always all the same size. So like, well, let's put it back to the way it was. Okay, so we do that, and now tet is oh, interesting. Okay, so we can't do that. Is there man? How do we copy? Let's say t equal. Okay, so first of all, let's run the program again to reset everything. All right, and now we'll say that but just in the rotate, we're going to say so new is going to be deep. We'll say copy deep of tet, or even just t tet, and then we're going to say wrap this. Oh. Okay, so we need a little more space in our console here. We screwed up tet again. So for each row in the grid in G, say G equals copy deep tet, and then collect keep this, and we're going to do this multiple times. We're going to say we don't know how big tet is, right? So tet, how do we say size of tet? Size of tet, length of tet, size, count, length. Yeah, so length of tet. Why isn't it? Length has no value. Oh, it's a question mark. Length of tet. Length of tet is 4. Okay, so length. We're going to say loop length question mark of G, and do it that many times, right? Loop is do something so many times. Yeah. That is empty. That equals copy P or copy I. There we go. And that's it rotated. Or that's it. That's the transpose. Right? Because we swapped the grid put G. Grind put. How about grid put? Oh. Okay. We got to reassign it. So G is like a temporary thing. We call it G0 or something like that. Okay, and then now we can say grid put G. Right? And so the original tet or grid put tet was like this, and then we rotated it. Or we transposed it. And in this particular case, we should use the copy deep of T, right? And then grid put T. And then if we do this, we should transpose it, and that will be a grid put G. Yeah, so that was a transpose. That actually is also a left rotation. I wonder if there's maybe the L one would be something that's it's not symmetrical. So grid put G and grid put L. Let's put the G last. So yeah, so now you can see that it's well, I guess there's just really no way to see this. They're all going to look like rotations. But you can see it's not the right rotation, right? Like if we start with it, so if we say n nums equals 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, let's do it with nums. I don't think we say grid put nums anymore, can we? Oh, we can. Okay. So grid put G. Yes. Okay. So it's a transpose. 1, 2, 3. The columns are now the rows. I just wanted to prove to myself that that's actually what it was. Okay. So what do we do? And then is there like a reverse of G? And so that was a counterclockwise rotation. So let's call this transpose. Transpose a matrix. Sorry, transpose a matrix is the F. This is too much. It's too much for one line in my terminal. So let's copy this and put it into a text editor. say transpose is equal to a function of some matrix I'm going to make it function, so this is a local variable. I'm going to say temp is copy deep of the m, and then we're going to return temp each row of temp. Collect loop length temp, and then we're going to say keep wrap collect for each row temp. Row. What's the problem here? That we didn't close it. All right. And so then, oh, does it say rotate? Function M. Can you guess what it is? No, that's not what you need to do. All you do is you say reverse transpose. Yeah, there we go. Reverse transpose M. So this will be either clockwise or counterclockwise. That was so nums. Let's load the call this rotate, and we'll figure out which way it is. I wish I could associate like a button for this, or I could search backwards in the history. So we'll say rotate. We'll say grid print nums. Oh, grid put nums, and grid put rotate nums. And that was a no, that was the transpose, right? Is this the transpose? Hang on. But hang on a second. Nums, reverse nums. Yeah, okay. So that you can say reverse copy nums. Reverse copy M. Otherwise, you're gonna put it in. You're gonna modify it in place. Reverse copy M, and then transpose, and then this should be clockwise, and then counterclockwise. We don't even need a function here. There's just func. It's going to be func of M, and it's going to be reverse. Oh, sorry, counterclockwise is going to be reverse copy, reverse transpose of M. So let's try that. So then we have grid put T, and then we have rotate T, clockwise of T. That's one clockwise, and we say clockwise of T. There we go. And if we say counterclockwise, clockwise of T, that should be, oh. Okay, counterclockwise doesn't seem to be working. Grid put T is that, and then so clockwise of T is that, and then counterclockwise is back. Yes, my love, what you need? That was working, okay. I was just confused. Okay, sweetie. Go watch your show. I'll be down in a little while, okay? Got a little girl down there. All right, grid put counterclockwise T. So these are working. So yeah, it's a transpose and reverse. The first time I implemented this, it was much more complicated, but since I learned how to do transpose and reverse to rotate something, it just seems a whole lot easier. Okay, oh, someone's watching, hello. All right, so that should, so which one do we need? So now we need to say, so clockwise L is when we do the right parentheses, and that is something that is not going to be one of these. So we say if command equals this, then we're going to say command equals, I guess, clockwise. So clockwise. Command equals clockwise. Okay, and let's see if that works. We go here and we say Tanko test. Ah, okay. So yeah, right. I didn't add anything here. So in here, we're going to say CW, and then we're going to say tet equals CW tet. And then counterclockwise, I would call it CC. Tet equals counterclockwise tet. Clockwise and counterclockwise. I guess technically we don't have that test yet, but Tanko test should work. Tanko next will be the, oops, Tanko test. Tanko next. Tanko test. Tanko next. Tanko test. So we just call it new line. Right now, is that real? I bet it's hallucinating. Print now. Yeah, print. We just say print. Okay. So we're not seeing the full test here, but maybe this is a good time to look over your code, see if there's something to clean up. I guess I should. The problem is you don't have the expected output in here. Maybe there needs to be a way to so the Tanko next should. I think what really needs to happen is that this needs to be showing the information, right? Yeah, so we pass clockwise O, and then there needs to be a button here to run your tests, and that way we could do everything from this window, and that's what needs to happen. Because otherwise, you put it in the term. A, the terminal is not going to be there for most people, and then B, right, because you're going to be running everything in the browser, and you're going to have like an editor over here. Like even this is not going to be here. This is all going to be like cleaned up a little bit. This is all going to be like hidden away, and you have like little boxes or something. And so you should just have the test prompt, but you want to be able to see this, and you want to see what the expected output is, and all that. So, but I'm just going to work through this. Tanko next. Tanko test. It's a little tedious when you have to type different commands. All right, so let's commit this gd redtris.red. you know, especially since they're all done at once, right? Like those are all like I'm just gonna put a note to myself, like clean up the rotation test. Maybe some of them, they should all work. Did I not do? Oh, I didn't even need counterclockwise yet, right? Because in the test we don't do counterclockwise. And that's because at the time I didn't know you could do it so easily. And so I thought it would be complicated to write counterclockwise. I'm gonna make a note of myself, like so counterclockwise was not easy for me in the past because I didn't know, or, you know, clockwise versus counterclockwise. I didn't know about reverse and transpose. Like I didn't know how to do it, so that was a trick, right? So the question is like, well, should I tell people how to do it? I don't know. But also, I think what I did in my original implementation was I just did clockwise 3 times, and that was the same as counterclockwise. All right, so clockwise and counterclockwise, clockwise and counterclockwise rotations. Okay, Tanko show. Where are we at? Now it's time to place the active tetramino in the matrix. The P command should print the matrix just like P does, but in addition, it should show the active tetramino. And you don't actually see that because so the text note, the text refers to diagrams that the user cannot see if they are reading in the terminal. So that completely breaks the workflow here. You can't see what the, like for example, spawn.o. Spawn.o shows the P command. Wants you to look at the output from the P command, which you actually can see, but you have to go here. So the expected output is this. So they should be in the middle of the top row. And the active tetramino is drawn with uppercase letters so we can distinguish it from the settled blocks. Here we see the O tetramino in its initial spawn location. Okay. So I need to put the, right now we can do P. I would say do commands P, right? And we can say do commands T. We can say do commands 2-word O, right? Oh, we should say main, and then we. So main has a bug. Because I want now this to be that global state, but I want this to be local. I want to be able to say S in command or local. Local is S in command. Is that right? I think that's right, but I'm not sure. Do load learntris.read. We'll see in a minute. Nope, that didn't work. Okay, hang on. Well, done should be false. Right, and S did not override the thing. That's good. Okay, so now we can say now we can say main, and we can say print and T. We say O, and we say T, and we get that, and then if we say Q, We're done. Allow restarting main, main from red. All right, so somehow we've got to make a new version of so the matrix is this, and we're going to say, like, you know, the combined version of this. If the next test is not to, I don't know what the next test is, but if the next test is not to know the location on.o, next test really ought to have to be about inspecting the location. Let's see if it is. Here's the code. I'm going to peek ahead because I'm just kind of like looking at the spawn.o. Oh, okay. Maybe that's fine. You don't need to know where they are. You don't need to know that. I think that's fine. Like, you as the programmer should figure that out, but I'm not going to like drill you on how you represent that internally. So I'm just going to put a note to myself here. But I don't think we should have to drill students about. They have to figure out their own solution. Okay. So how do we do this now? Right, if I have t here, or we call it tet, right? Let's say grid new 5 of dot, right? And put matrix put grid put tet. And the question is, what do we put? How do I get like, how do I get the O tetramino in here? I think I just do a for loop. I just do nested for loops. Like, it's going to be something like this. So like, call it like stamp or whatever. We'll call it blit, or we'll call it stamp. How about copy grid stamp, and we'll say G and S. We'll call it blit. So blit S onto G at X and Y. All right. I'm going to say, this is a func. I'm going to say temp equals copy deep G. For each row of sprite. I think you actually say it like this. I think you put the description in here. Copy sprite copy sprite S onto G at XY. The grid G at XY. I think this actually goes in here, but it doesn't matter. Well, it would, because let's try this. Let's put this here. And then if I load this, do load learntris.read, and then I say question mark blit. Nope, that didn't work. Blit is a function value. Let's look at how they do it. Load func. Oh, so you put it right before the. Like it matters because we're. All right, so do that again. And then we say blit, then it will explain what it is. Yeah, so blit is copy sprite S onto grid G at XY. Okay. M rotated clockwise. M rotated counterclockwise. The Widdershins, as Terry Pratchett would have said. His Discworld novels. Okay. For each row of S. All right, so we're going to say like Y, or how about we say GY equals Y, GX for each row of S, GX equals X. For each C in the row, I like that it guessed that this is so G. It's more like row X. I don't know what replace is. What does that even? I don't think we need that because it's not a functional. It's not functional. We just do the assignment. I'm sorry, GX. But GX, we don't even need a GY. Yes, we do. Because if we're going to say that it's going to be S of GY GX. No. It's more like GX equals 0, GY equals 1, and then here. Yeah, so because it starts at Y, we'll say GY plus 1 at the start of every thing. GX equals 0, and then for each, we'll say GX equals GX plus 1. And then row say row GX plus, all right, it should be more like SY, right? SY, current Y, right? Current Y current y is equal to current y plus 1, current x equals 0. Current x equals current y plus 1. If this is all zero based, this would be a much easier operation, but we're going to have to say at x plus current x minus 1. And the same thing here. I think we can say this, right? So t, we'll say tet at 3, 2 is equal to 4, equal to this. And I think actually this is not going to do what I want. Yeah. What is tet at 3.2? 2. You can use it to read that way, but you can't. Maybe if you put it in this, in brackets, can you do that? No? So we're going to say G row is going to be grid of x plus dx minus 1, which that actually we can do here. Say S row of S, G row is going to be this. And then for each C of F, for each, yeah. Then we can say if C is not equal to the empty dot, then G row, this is actually y plus cy plus cy plus cy minus 1. You have to put spaces in between all of them. X plus cx minus 1. And that's it. A little clunky, but, and we can put this on the same line. Actually, let's do that. Let's just spawn an O, and then we will print it with cap P, but that doesn't exist yet. All right, so we have to do this blit thing. So blit, so matrix is this, then we're gonna say put grid put matrix, and then we're gonna say grid put blit. And what is blit? Blit is copy, so blit T onto grid at 5, 5. Oh, grid has no value. This should be G. And this is how you do the indexing. GY has no value. And this is CX, and CY and then CX. For each does not allow none for its series argument. We want to say for each S row in T matrix, for each row G print row, for each row in G. Oh, okay, hang on. We don't return anything. So then at the end, we have to say have to return temp. Not quite. Okay, matrix, just reload. Ah. So I want to get this. This is going to be the first row and the first. All right, so 0. Oh, I should have called that G. Oh, really? This should be temp. Maybe that was the problem to begin with. Grid put. That almost worked. One, two, three, four. So it's not in the right place. And what does T look like? Grid put T. So it's too high. Well, first of all, it should be Y. So that's probably it. That looks right. 1, 2, 3, 4, 5, and then it's here. I think that's right. So that's this. And so we'll say capital P is going to be grid put split at matrix tx ty. And we'll say tx is going to be, well, ty is going to be 0, and tx and ty is going to be, we don't know. tx is going to be something, wherever that needs to go. But so in the test, if we go here, so first of all, this is it's nice that we start with this because this is the actual place. So 0, 1, 2, 3, or 1, 2, 3, 4, 5. So at 5, 5, 0. All right, let's see if that works. Tanko test. T it at 1. So it's at 1. Looks like it worked, but we have to say uppercase. So no. Map has no value. I just figured out how to learn to write maps. So you say map. So to refer to a function, you have to say like this. So you say you have to say map uppercase this, but map doesn't exist. So map would be a function that takes an f and an x's, and it says collect. Or, sorry, x is collect, and for each x and x's, keep fx. And then you would say map uppercase copy t. Except it's nested. So row would be map uppercase on the row. There we go. T. Oh, we'll say map, say wrap. There we go. I guess that's each. Map 2 would be this. Map 2. Map 2D would be a function that says map, that says it takes an f and an x's, and then map this function to a copy of x's. So then map 2D uppercase t. But t is now uppercase, yeah. Copy deep of x's. So and if we say t lowercase map 2D uppercase t is that, and then t is still lowercase. Yeah, okay, so map 2D is this. Oh, actually, that should be f. Let me double check that this works. I think we have to say f here. Yeah. Or colon f is what I meant. So map 2D is this. Let's take this. Map yeah. Or we could put the I'd probably put copy here, and it fixes both problems, right? Because then we're using map recursively, and it should work. Let's try that again. Oh yeah, paste that. So map, 2D, yep, and then just double check that worked again. That didn't work. I'm not convinced. Load, do load learntris.red. T is this. T, and now T is what? How is that? If we did a map, if we did a copy of map, try that. Interesting. Well, if we put copy deep here, it'll definitely work. Then you're doing 2 copies of the thing. That's okay. I'm a little surprised, but I would expect that to. I would have expected that to. If we do a copy of X's, then each row we're going to copy as well, right? So why would it? Maybe I needed both of them. Okay, hang on a second. It could be that the string itself is being mutated, and then that's because we're not sharing a. Yeah, I bet that's what it is. The string itself is being mutated, and so even though we're passing references to those, we have to deep copy that. I almost want to say upcase, rather than doing the deep copy, just do upcase is func s uppercase a copy of t of s, right? And then we do this. So hang on, t. Let's reload it. T is lowercase, and then if we use my thing, t is still lowercase. Yeah, so we got to copy that. So a non-destructive uppercase. I don't know why that's destructive. Okay. That doesn't have to be there. All right, so then when we do the stamping thing, we would say upcase. Map 2D upcase of TET, something like that. Well, yeah, let's just, so say clear, O, and then P. And there it is. And I think the test passes now. 22 tests pass. Print the matrix with active tetraminode. Okay. And then Tanko next. So we just have to have the spaces for these. So we need to move it to the left one. So I guess in here we're gonna say tx equals 5, 1, and here for sorry, that was O. 5, 1, and then for the t we're gonna say tx. First of all, copy I, and then tx is going to be 4, 1. Oh, so wrong. One, 2, 3, 4. Why didn't that change anything? Because I put it on the T instead of the thing I'm actually supposed to do, which is the P, the L. Okay. And go next. On location for J. Oh, there are no spaces between the commands this time. That's annoying. There's a reason for it, and that is so that you can run it one character at a time. I'm wondering, like, I wonder if I'm being unfair, but like, So the point is that we have to be able to parse this input now. All right, so let's commit the ed learntris.read. What do we have? So we have some initial spawn locations. Learntris, some initial spawn connection, some first initial spawn locations. All right, it's not that annoying. What do we do? All right, so we say for each character in, and we don't do this. In S, for each character in S, it's actually kind of nice because you're writing a tokenizer here. Like it's annoying, but if command is equal to continue, right? I believe continue is a keyword. Top of loop, okay. So if command is equal to that, continue. If command is equal to state equals inspect, and now commands, or actually we're going to call it C. Commands. Okay, so this is the oh, that's actually fine. We can just say command equals question mark S. So by default, command equals C. If state is not inspect, do this command. And then if state is equal to inspect, state equals normal. State is normal. State is begin. If state is equal to inspect, then state equals begin, and command is equal to this. There we go. I want to like rename that to like, how do we do it? I just reach CNS. Okay. I'm missing a command somewhere. How about where we say if state is equal to command, begin. State is equal to normal. Copy does not allow care for its uppercase copy command. C equals uppercase copy C, and then this should be C. There we go. Plus 0. Which test failed? Core S failed. So we didn't get a 0 for that. So if we do question mark and the character S, okay, that should work. I think this is failing. We still have to say copy C. No. No, and that wouldn't be what's causing it anyway. I think this is failing. I will say C is, so is this equal to this? False, okay. We have to put this. And what about, interesting. Okay. So we got to put special commands for each of those, or special syntax for those. All right, we could just use this. Oh, even that doesn't look right. Let's just do it for all of them. So the problem is that I is not being recognized now. So the capital I is not being recognized. There we go. If rejoin C is equal to uppercase rejoin C, there we go. And now the rotation is not working. Contains invalid characters. Command is equal to rejoin C. Or maybe this is right. This is right. So this seems to be wrong. That should be right. What am I doing wrong here? But that's not gonna, I can't run that one test, can I? Tanko needs a way to run exactly one test. By name. Also, should at least show the name of the test that is failing in the terminal and have a link to the other thing. So, so script error contains where to and two-word command. All right, but we know what the characters are, so it's this. So if we just run we run this code in the so command is command is oh, it's failing on the uppercase. Interesting. All right, so now let's call this command, and then we'll say whatever the command is, right? Rather than doing that, uppercase rejoin C, let's say command. Right? Let me say uppercase command. Is no longer destructive. You used to say uppercase copy command. Right, so now I think this works. Yes, except I am printing out the command name. Alt I should pass. Oh. On J failed. All right, so we just need to move this over. Like we need to move it over one, so this should be the same as for J. And I think these are all the same size. I'm just going to guess what these are. I'll not. Allow single allow lack of spaces. Allow commands without spaces. We should probably give like some little talk about this, right? I don't know. Or at least some warning, right, that it's coming. At least should give some warning. I'll have to give some warning that this is coming when we first introduce. All right. All right, so Tanko next. Where the Z location found. Tanko test, see if it's right. And will tell us we need to move it over 1. Right? Wait, hang on. Oh, that's a tricky thing. So the first line was here, and yes, it moves to the left. And probably T is the same. We'll find out. And that was wrong, so that one needs to move over 1 as well. And we need to move the T over also 1. So basically, they all spawn in the same place except for that, except for the O. Oh. Okay. That said it was the last one, so learntris.red. Spawn locations. Final spawn. Rest fill in remaining spawn locations. Okay, Tanko next. Really should update this. Okay, so Tanko next. The less than command nudges the active tetramino 1 cell to the left. I'm going to do this the naive way and see what happens when the tests say. All right, so if C is equal to this, command equals left. Go I don't think you have to escape that one. That's not a special character. Go left. Actually, we just say tx is equal to tx minus 1. Clearly, something is going special here. So, okay. Go left. How about we say nudge? Or how about we say LF? Tx equals tx minus 1. Just a step to the left. Okay. What's wrong with that? Oh, because I didn't call left. So if C is equal to command equals LF. All right, next. I assume the next one is to the right. Yes, nudge right. Nudge. Starting to think there's something I could do here with the lookup, but I've already kind of done that here. But I don't know what to do with the. I don't know how you make a lookup table with keys that are not. I didn't assign it, did I? I said left again. Downward by 1 cell. Ty equals ty plus 1. That's kind of interesting. You don't have to see this exactly, but that didn't work. Onward young tetramino. And we didn't do V. Yeah, I could have called that V here. Let's call it V. Of course, you can't go up. Yeah, that's where I figured we should do. So, there min probably min 3 5. Yes. And what if we say min 3 5 plus 6 3? We say min. Yeah, okay, 5 plus. So you can do that. We'll say, but we actually want the max of this, max of 1 and the min of 10 and tx plus 1. It's trying to escape on the right side of the matrix. Okay, Tenko test. That should pass now because I already did it. Oh. Oh, okay. But it's not. This is not right. Minus. What do we say here? I'm going to put a note to myself like, okay, so what happens if you rotate this tetramino? You figure out it's 3 things wide, but then you rotate it and it's going to be, what happens when you rotate the tetramino? What happens to the edge detection when you rotate the tetramino? Should be a test for nudging things that are within their bounding box. So it's more like 10 minus the right side of tet. So like if we have a tetramino that's like this, 1, 2, 3, 4, and then we've got like this. I wanna say Well, like what is T, right? T. Okay, so 3, that is a 3 by 3 one. Why can't I switch? But like the J one is this. So J is grid put J, grid put clockwise of J. See, the width changes. So here it should be minus the width. And this is where the coordinate is. So it should be able to move over one further when it's counterclockwise. It should be able to move over one further. So that we got to find like the right edge and the left edge. We have to know the bounds. The right side, what I want to know is, I want to say instead of this here, I want to say -3, and here I want to say 10 minus 3, so 7. And the grid is, the matrix is 10 things wide, and we want to limit it to step 7 here, but here we want to limit it to step 6, or I'm sorry, step 8, because then it could have, this could hang over the side. This is fine. Although it could break there's some bounds checking that needs to be done now on the stamping part. Because we'll be able to move it over to the right. So okay, that's fine. I guess I want to give some people like reassurance that at this point, so as the author of this test, I want to give some people reassurance. So this is actually a really hard test, or it's not a really hard test, but it's collide wall. Let's put some reassuring text in here that will cover all the cases one by one. All the literal edge cases. Literal edge cases one by one. So in this particular case, we could say 7. We could just hard code the number 7. And let's see if it lets me pass. If it's rotating within a square, we can, like the T tetrahedron, we can just say that. So we can say length of 10. Let's say 11 minus length. Ah, see, yeah. Yeah, this is going to fail. Because it rotated, and now it's thinner, and it can move that way. The length is not sufficient. So we got to say right side. Say right edge. Of sprite. Right, yes. We'll say res is going to be 0. And then for each row of res, no, sorry, find, no, sorry. So yeah, so we're going to say map f, map func row, find row, find row. If I could find the last, that would be one thing, but I need to say, we'll say res equals length of s. Res is length of s. For each row in s, I equals length well, no, so it could be 0, right? It could be 0, completely 0. For each row of s, what am I trying to say? I guess I've set it to the right hand side, thinking that if it's a completely if the tetraminal were completely blank, it's all dots, then we could move it all the way to the right hand side, and so the width should be, the right edge should be 0, right? And then if so it's more like loop length of s maybe even I equals length of s. I equals length of s. If no for row in for row s, for each row s, for each row in the sprite, we're going to loop I through the length of the row. And then we're going to say I is equal to I minus 1. If row I is not equal to that, then right, first of all, right, if I equals res continue, we'll break on this. We'll break on this inner loop. So if we reach the edge that we already know about, then we don't worry about going further past that. Right. But now if rho I is not equal to that, then res equals I, and then I equals I minus 1. I think that's it. And that's the right edge. That gives us the right edge. Right? We'll see. The word command contains invalid characters. Okay. Do load learntris.read. And we'll just type these characters in by hand. So see that. Oh, this is the first time we introduce left rotate. So we never explicitly introduced the so collide right wall 2. I'm annoyed that we introduces the left the counterclockwise rotation, which is fine, but also does some checking. Tests should not test for two things. I'm thinking there was another test here, like the very first shape test. Well, okay, so this does introduce I and T, but that's fair. And this introduces the score, real clear, clockwise. I think we need counterclockwise to be introduced separately, and then spawn O. This also introduces the active tetramino, but it needs a spawn location. So we need P. Like you can't really have P until you've spawned a letter. So this is not really introducing two things at once. So really, this is fair. This is fair. Nudge is fair. But I think nudge should include enough. The nudge tests. Nudge tests should include enough. Should include reassurance that we will handle the edge cases. About edge cases. I think I already typed this. Yeah, I typed this already. Okay, but this one in particular is like because here you have to introduce a bunch of things to make nudging work. And I think we just want to separate it out, and we'll talk about what happens when you hit the edge in a little bit. Okay. So we did collide left and collide right, but now we're going to do this. Okay, so this actually is collide right while 2 actually is. I guess it's not that it's two things. So collide right while 2, collide right while 2. Oh, I see. Should just do left rotation. It should just do clockwise, or introduce clockwise separately. I think maybe we should introduce counterclockwise, like right here. Like I think we should just add it right before spawning. All right, so because it forces you to do two different things in the commit. That's not a big deal because I actually implemented it. And even if I hadn't implemented it, right, you just do counterclockwise 3 times. It should be a separate test. See, because like now I'm committing left and right nudging and counterclockwise. Wait, it doesn't matter. It should just be grouped up there differently. All right, so we'll say T and print. Oh, sorry, T and T. Then we'll say rotate left and print it. Not rotate left, counterclockwise, and then rotate this way and print it. Yeah. So if you start, if we say T and we say rotate T and print it, this should be the same as T and that, and it is. And this is why you don't have spaces in it. So you can just type little commands here. You make a little language for Tetris. All right, so why is it failing? Nope. Because we still have this and we're not calling right edge. That's why. Right edge. Why does that happen sometimes? I thought, sometimes Control Q. Somehow I've broken it. Okay. I don't know why that happens every once in a while. I know I'm hitting some key but the key I thought would fix it didn't fix it. So CD ver learntris, and we'll say, oh, now it works. Minus does not allow unset for its right edge of tet. It didn't return anything, so we have to return res. No, not return res, just res. Is return a word? No, returns a value from a function. So you can use return, but you don't have to. Value out of range 11. Yes, I expected that. Okay, so here that's the thing I expected we'd have to do in split. If Cx is greater than G row 1, G row then length of G row, then I guess break. No. Right, so we need to say Gx is going to be this value right here. You have to put it in parentheses, otherwise it's looking for the literal Gx. Out of range 11. Gx is greater than that. Okay, what do we have here? I'm not yet saving the last values here. Now, why did that happen? I didn't do a wall kick here. This is not a wall kick. We're not talking about wall kicks. Wall kick would be you got to the right and then you rotate again, and now like you would have moved outside of you have to readjust the position. What's happening? We move to the right, we move farther over. All right, so let's see what. What's the right edge of T is 1. T. Oh, that's wrong. I know why, because this needs to have a break in it. So in the my loop, I'm going all the way to the left. We need to say break. Right edge of T should be 3, and then right edge of clockwise t should be 3, and then counterclockwise t should be 2. So put gt grid. It's the worst name thing. So yeah, that's right. That's what I wanted. All right, so now Tenko test. Tenko next. Right, okay, so the left and right collision detection is done. GD redtris dot red. There's got to be some little flow where you can add this to your list of tests or not. You really want it to be all green, but you ought to be able to see the test without. Like, the button should say like accept, and that's what Tenko next should do. Or Tenko change should just put you back into change mode without, now that you've seen the test. I did talk about this in the last one. Okay, so but there's also a missing test here. What about the left edge? What about collision plus rotation on the left edge? I think that is a bug. And we're missing a test. Missing a test before slide.floor. Right edge detection. Left and right. Move, nudge left and right. Edge detect on right. We should really encourage people to write their own tests like unit tests. I mean, it's kind of redundant, but I don't know. Maybe we shouldn't. Maybe that's silly. Once upon a time, a T tetraminnow spawned at the top of the well and used the V command to move down one cell 24 times. Sadly, it was unable to burrow into the earth and spent the remainder of its life standing on its head at the bottom of a well. Use Tenko test to run the test. And so V does nothing right. It's probably going to say complain that it doesn't unbreak. Okay. Or with none. And this is also edge detection with the bottom of the well. So we need to check here. I'm going to call this GY. GY equals GY plus 1. Hey, what? This is CX plus 1. GY is equal to that. CY equals 0, CY equals CY plus 1, GY equals Y plus CY minus 1, And then if gy is length, we just say gy equals -1 here. -1. And then gy equals g, well, whatever, it doesn't matter. Even though that's more efficient, I feel like this is clearer. And then if gy is greater than length of temp, then we break as well. Otherwise, gy, yeah. All right, so previously we had an error, and now we have the floor, but it went through the floor. And so we need to test so Vy is going to be the same as min of 22, or yeah, 22 minus 23 minus top edge. Okay. Oh, I gotta go. 1 minute here. I gotta watch the kids. I'll be back in a minute. I'll put a little note up on screen. I'm coming, sweetie. I need to have like a solution for this. Be right back. Taking care of it. All right, sorry. Be right back. Okay, sorry about that. Hopefully I remember to cut this out. Cut around the 2:15 mark. 2-hour, 15-minute mark. Okay. All right, well. I think I'm done with no, I had to get the top edge, right? Top edge of sprite S. Let's see, it says res equals 0 for each row of S. If find row, nope, we gotta start with 1. If find row of, oh no, we want the bottom edge, right? We want the bottom edge. So how about we say a reverse S, res equals length of S, break, otherwise res equals res minus 1. No. No, what I want to say is if for X, for each C row, yes. We want to return the res. And then it res equals res minus 1. That's correct. Yeah, that's correct. And yet, this should probably be build nudge T, right? Because when it's a test that's failing, you're not fixing it, you're building it. So it did not actually work. I will do P, and then we'll print it with capital P, and then we'll do V and print it with capital P, and it moved twice. It flipped. Because reversed. Oh, okay, reverse is we'll do func reverse copy. Yes. And so when I say rev, that's what I want. I want reverse, not rev s. Because it's reverse and upcase, they're like destructive. Okay, Tanko next. Take the plunge. All right, so V did nothing here. All right, so capital V. And even this is not right because we have to compare it against the what happens when they're in the well, right? But or what happens when there's other things in the matrix. But I would say loop 23 down. And I'm going to call this down. If that's not right. Because I ended it here. I put too many. Line 145. Something is broken. What's broken here? Oh, because I didn't end this. Probably I copied that and I missed one character. Seems weird. Oh no, this is right. But now we have to do stamp. And stamp is stamp grid put blit map 2D, but it's not upcase. Blit text at mtx tx. That's it. X at y. Whatever the thing. Yeah. So no, it's not this. It's pet. Yeah. No, not tet. The matrix. The matrix is equal to blit the current tetramino onto the matrix at its position. Tanko test. That's it. See, had we typed capital P here, we would have seen the capital thing here, but now it's not there. Yeah, but now it's stamped into the well itself. Right. Read. V command to plunge piece to bottom. Plunge tetramino to bottom. I don't know how many tests I've done. Top floor. So we need progress, right? We need we've lost a sense of progress here. Lost sense of progress. Although if we say how many tests there are, Tanko test. Oops. Sorry, Tanko test. Should say how many tests? 36 tests passed. So we have 9 more tests to go. Should be, should show something in the web. Okay. Be right back and get. I'm gonna put a note to myself to make a nice be right back screen. I'm gonna cut. Probably gonna cut this down and just do the interesting parts of this as well. So I'm just gonna make one stream that I just do all the tests in order. And I'm also probably gonna. Well, I'm not really sure. I'm not really sure what I'm gonna do. I got to present learntris to the world here soon. Okay, what's next? Tanko next. Aside from demonstrating the astonishing grace and agility of your average tetramino as it plunges sideways to its doom, this test double checks that your collision detection holds up under rotation. Tanko test. Yep. Tanko next. Here we have our first test of collision detection between a falling piece and a block already in the well. That should be where there should be matrix. In the well, in the matrix. When the second hard drop is issued, I called it plunge a minute ago, I think. Oh no, it's just hard drop. I used the word taking the plunge, but it's actually hard drop. But it's drop, it's fine. Okay. So we're going to drop one, and then we're going to drop another one into it. I think what I did in the past was something to do with, just basically checking to see whether I collided at every step. I think there's a better way to do it off the top of my head right now. But first of all, this should fail, right? Because this is going to superimpose the R on top of the M, and then we're just going to lose the M. So they're going to go into each other. No. They merged, they got melded together. What I'm thinking is basically we're gonna take just a piece like this, like a segment. How we're gonna know the current location of the tetramino, and then like I'm thinking make like a little like say this has. So let's see what the right. So if we say Z and then we look at it, that's the current tetramino, and it's somewhere in the matrix up here. Well, I think what we do is we figure out like a profile of this thing. And then also in the matrix itself, so we're going to scan upward here, and we're going to find like a number for each one of these things. Like saying this one would be like, so if we just print out the tetramino, we're going to say that this one can move down like 2, or maybe just how many spaces do we have? So we have 2, 1, 1. And if we rotate it, then we have 3, 0, 1. So how can I get that? So we say tet, and we say transpose tet. Then we say map, and we're going to say func x, and then for each one of those, we're going to say none, none, none. That doesn't seem right. Hmm. So a block has something like a head at its first index. 313 of transpose tet. So grid put transpose tet. But what happens if it's if we say I instead of I? 4444. So grid put transpose of I is that. Yeah, I don't want to search for the. This is not what I want. I want this should be 4. But first of all, yeah, I want the character. I want the thing that's not a. I want the thing that's not a dot. So let's make a last cell. Last like this. This right here is what I want. Not bottom edge, but last in row. Yeah, last non-empty cell. I would say row last. And res is equal to length of row of R for each C of rev R. If C is not equal to dot, return C, return res, and then res equals res minus 1. And at the end, we return 0. Right. Which is this. For each rev R, we don't even need the parentheses. Oh, this is slightly different. Because here we just say, right, because it's a nested loop, and here we're doing it here, but here it's inside the thing. So row last. Okay, so let's load this thing again. Say row last of I. No, that can't be right. A map row last I. And I'm going to give this a better name. I'm just going to call it P. So we'll do P of that. Right, because I didn't load it. Zero for row last of I. Interesting. And then PI is this. So row last is 4, 0. Okay, so I want to do the transpose of I. Map of transpose I. 2, 2, which is right. I want that. I say so each one can go down two steps. But if I do T, it's that. And if I do O, row last. Oh no, it's not. So it's not counting these. It's counting the last in the row. So that this is like bottom. This is like the bottom profile. I already had bottom edge, but this is like the bottom. Let's call it right extent and bottom extent. And then first let's right extent, and then down here we use bottom extent. And then bottom edge. Bottom edge is going to be a func. Be row. Going to be map row last the transpose of S. We don't have that yet. Let's reload. So bottom edge of I is and clockwise of I, and then clockwise of I. Yeah, so it's down even lower. Okay. So in other words, we're treating that as the height of the thing. Okay, and then now I want to do the same thing. Figure out how many spaces can I drop. So if we say tx is 1, let's actually do the test here. So it's, what is it? Say TV, T and drop it, then Z. Okay, so T, or main, T, drop it, Z, and that's it, and then quit. And then if we print the matrix, we have this. And if we print split the tetramino onto the matrix at tx, and we have this. This is the scene, right? I'm gonna call this PP. How about it was called game? Oh, put game. I'm gonna change the word grid put to put grid. Yeah. Put game is func. I'm gonna change this to put grid. Reload. Put this in the code so we don't have to. All right. So PP. Nope. PP. What did I call it? I did not call it PP. Oh, P game. PG to print the game. PG, that did not work. Oh, because I don't have a Tetris. So we say T, drop it, and then Z, no, main, TV, Z, quit, and then PG should print it right there. Okay. That's my thing. So and what I have, I call it bottom edge. Is that it? Bottom edge of the tetramino is this. We have one space. No, we have. Right. So it's saying this. These are the coordinates of, yeah, where it is. And I want to get everything in the grid underneath this point. I want to like extract that. Everything that's in the shadow of the thing, I guess. So how would I do that? first of all, everything. So if we move it, like I'm going to move it down like a couple. And then game. Oh, interesting. All right, so I have to, yeah, when I did that, it wiped it out. So make a T tetramino, drop it to the bottom of the well. Make a Z tetramino, and then move it down a couple times, and then quit. And then the game should be like that. Okay, so I want to like cut off the top part. So that's TY, their drop. No. But I think you can say TY, like, see, you can, like, skip. So P matrix versus P skip 5 matrix. Skip matrix 5. Okay, so what if we said, so matrix, maybe I'm going to extract this as well. Reload that, get the game. I got to do it again. I almost want like a little set of input here. Like maybe eval or exec. Is there a word exec already in here? Eval. We say exec. Oh, I'll say run. Yeah, we'll say run s. And we'll say func s locals command. Now we just say run trim input. Say run, can be a function s. I'm gonna take this out temporarily in a second, or just commit part of it. Where's state? State is I don't even think we need this loop anymore. This can go away. See, this is where I should be doing this. I'm breaking the rule of doing this with a failing test. Right? Accepted a failing test. Reach C of S. run string s through Tetris interpreter, through game interpreter. So reload. Func does not allow a word for its body argument. Runs. And then we need a. And then we'll say. Down here. So now if I say run spawn a T, drop it, spawn a Z, move it down a little bit, and then quit. Yes, my love? Okay, come here. Her laptop is dead. I gotta go here in a few minutes anyway. What if I say, so we have the game. So G, I'm gonna say G equals game and print that. How about PG over here? And then we're gonna say P G skip 5, skip TY, skip TY. Right. Hey, sweetie beatie. We gotta charge your laptop. Oh, TY minus 1.
My laptop's dead.
Yes, your laptop's dead. I charge it right here. Can you just sit there for a minute? We're gonna go get Dee Dee in a minute, okay? We gotta go pick her up from the bus stop. Almost.
Fire?
Hmm? Flying what? No. And then what? Let us skip. Can you do the reverse? No. You can say take though. You can take. Right. So if we say, right, so if we said the tetromino width equals length of tet. Okay. And then we're gonna say map. So let's go back to here.
Yeah.
And I'm going to map something here. So map. Sorry, sweetie. Map. And then so of the rows that we have left, we're going to say copy the row. And we're going to take we're going to skip copy row ty minus 1 or tx minus 1, and that should give us the oh, f has no value. Func is what I meant to say. Ooh, that's wrong. So we want to wrap that. There we go. And then we want to, from that, we want to drop so we just want to take, we want to take those pieces. So we're going to say wrap skip. Oh, come on. You're going to fall? Don't fall. All right, so we want to, so we've copied the rows and we want to take they take t width of that. Oh, take. I don't know why. Okay, so from that we take and then t width. Ah, I see. We take. We have to say part. There we go. And now we have it. And now those are the pieces. And then but now we only want to take this from not from the game, but from the matrix. And so that's the profile of the thing that we want. And then if we reverse this, no. And then if we take the bottom edge, oh, come on. Oh, because we can't P. So P. There we go. What did I say? What's bottom edge? That can't be right. Bottom edge should have a transpose in there. We did. Okay, so row last, transpose of S. So you would think there'd be 4 items in here. So first, rev map. So print that. So bottom edge. No, that cannot be right. Row last to the transpose of S. So if we transpose this, oh, that's not transpose. Transpose is wrong. It's assuming it's a square, but it's not. So we got to do it. So let's see, transpose. Make grid. Make grid. Nope. Grid new. Grid new. 7.3 of X. Hmm? No. Yeah, you can try watching it. But it's probably not. You gotta see if it works. Mm-hmm. Oh, the transpose is cutting it. So if we print this, grid new, that works fine. The transpose is failing. Okay, so transpose. Need to back up and fix this here. So transpose should be this. All right, so let's say H is equal to length of M. Loop H times the width is length of M1. Okay, so reload it, and then now what is transpose here? There we go. That worked right. Let's see if it works. Okay, you see if it works. I see if this works. All right, so now what are we trying to do before? We've got to go back to what we were doing. This thing. Boom. But the matrix is broken, so we're going to say run again. Run D V Z D D D D D D D D, and then quit. What if we don't do this? Does it go in infinite loop? No. So we don't even need the cube. How about, but we clear it first. Otherwise, who knows what would have been in there. And then so now we can say that's the section we what? That didn't work. Oh right, and then we've got to we can't drop it yet. There's no command to like drop it on there, but we can print it. So we want to get that little chunk, which is much smaller than that, and that should be this. And if we say game here, that will show it. Yes, it does, and it's upside down. So we say matrix, because we have reversed it. And now we just want to find the bottom edge of this. This is how much space we have to drop. So we can say, hey, Daddy. Yes, my love. I don't have the number works. This number works. So let's see. This is like the zone, drop zone. DZ. Actually, really, this is the drop zone. Is DZ is this. So we print the drop zone. That's this. This is like the shadow of the current block. What can't you see, baby? I lost my place. You lost your place? I'm sorry. I lost I want the place now. Yeah, well, it started over because you restarted your laptop. So drop zone gonna be this. This is the what? You want to what? Incorrect password. Okay. Trying to get into the password stuff. There you go. It's gonna go in here. Give it a second. Okay. Leave it plugged in. Okay. Oh, it's 3:15. I gotta go. So I gotta go pick up my kid. So I'm just gonna leave this up on the screen, and I gotta go right now. I'll be right back. Dee. Downstairs, go say hello. Yeah, so much for that.
I miss her.
You miss her, then go see her. All right, well, this is my situation now, so couldn't even find my shoes. I had to go out there and in the snow. The bus stop is like half a block away. All right, so what is this? Copy row. This is like a slice. So slice would be like is a func. It's like AZ of X's. Yeah, no, but I don't even need that. Let's break this. So wrap, take, part. So take part, skip X's. Start playing. Start -1. I believe that's correct. We'll find out. Slice 1, 2, 3 of A, B, C, D, E, F, G. Okay. Oh. Right, because that's not how you call functions. ABC, that's right. And say 2 to 3, that should be the next, it's a moving window. 2, 5. Yeah. And this is probably like some of these things I think should be primitives, you know, coming from APL or whatever. Like that's not really a primitive in APL, but you could say like take something. You say skip and I mean, I guess they are, but they're destructive and there's mutable state here. Right? So I guess you just got to get used to it. I'm just not used to it. Right, so drop zone. Let's see what the drop zone is. Let's see if we can duplicate that. So we definitely see skip the matrix ty -1. That's this. So skip matrix ty -1, that part we keep. And then this is map func x is slice. So we're going to say wrap slice tx -1 tw. I think slice already does this. So we just say tx and tw. Oh, but we have to say of x. And that's it. So drop zone is func. There you go. But what is TW? TW is just length of the TW is length of a tet. The rectangle, including and below the current piece, current tetraminal. The slice of the matrix, including and below the current tetraminal. Okay. So let's reload that, and we'll see what DZ, not drop zone. Oh, we gotta run it again. We gotta run our little program. So that, and then if we get the drop zone, print the drop zone. And it's just that piece. Okay. Oh, I should have made a note to myself to somewhere around 3 cut around the 3 hour 10 mark or something like that. Okay. And if we say, so DZ is going to be this. DZ is the drop zone. And then if we say the height or the length of the drop zone. And then I wonder if you say func. So we'll say F equals func. P equals length drop zone. And then F is that. But if you say this, what happens? No, it doesn't evaluate it. I figured I learned how to actually modify this function. I had a little demo I wanted to do. Somebody on Gitter, the Gitter for Red, explained this to me. Talking. Like they pointed out a function. Basically, if in order to refer to a function's value, you say this, and so you can say f equals. I bet I can just do it from memory. F equals func x, and we say x plus n1. So if we say b is body of f, and then you say bn is 2, then if you look at f again, it has changed that to a 2. So you can actually modify a function and modify parts of a function like that, which is kind of weird. Kind of crazy. And so that would actually be an optimization in this particular case, but it's kind of silly. I'm not going to do that. All right, so I have the drop zone. Okay, so print drop zone and print game. So everything in here is my drop zone, and I want to figure out how far I can go down. And so if I take the size of the drop zone, no, the length question mark of the drop zone, that's 17. And then if I reverse the drop zone and take the bottom edge, which is what I did earlier, right? So then I want to like map. I know I say map func. I wonder if you can like close how deeply you can close over something. So if we say LDZ is length of the drop zone, and then we map function LDZ minus E minus X. So I want to get 17 minus 1 minus 2 minus -1. Yeah, okay, that worked. I feel like there's like a shorthand for this, but I don't know what it is. Is it like, maybe I'm hallucinating this. 3 plus, maybe there's not. No. Yeah, there's some way to do that, but maybe I'm just mixing up another language. All right, so I think that if I have this number and I have the tetramino, I even want to like, I almost want like a zip. So I take like the bottom edge of this and the bottom edge of, so this thing and the bottom edge, and I want to subtract the bottom edge of, so let's say this is like the drop height would be something like this. Drop height would be something like this. That's my drop height. And then I have a zip. No, so zip would be, zip is a function that goes, it takes a function and x's, oh, this would be zip width, right? Zip width would be function that takes, we have an f and we have x's and we have y's. And then for, we say select loop length x's, and then we're going to do keep f of x's we got to give it a name. We have to have like a name as like for the iterator. I is 0. We can keep f x's. We're going to say x. We say I is equal to I plus 1, and then keep x is I and y is I. Okay. Except that not I, it's I in parentheses because we want to take the value of I. Right, so we say zip width plus 1, 2, 3, and 11, or say 10, 20, 30. Operator plus is missing an argument, so I just take that. I actually need to wrap that in a function somehow. xy, x plus y. There we go. I bet there's a way to do this operation. I don't know what it is. All right, so anyway, zip width is my function here. Hmm. I don't know what you do with an op. How do you make op? No. So yeah, this is, can you say just get? Oh yeah. Okay. So So there we go. You can say zip with get that. Nope. Oh, but it's an operator, so so it's not. It wants to go in the middle. So that doesn't work. Interesting. So if f is get plus, or even if just say f is plus. Okay, you have to do that. So you have to say get now f is this. We can't say f34 or 35. We have to say 35f because it's an op. Interesting. Okay, so that's kind of cool. You can make infix operations, named infix operations. Really, you could make an APL out of this world here. Except I think you'd have to put the like the modifiers first. So you can make like Weewa out of this, I think. All right, where am I at? And of course you can change, the whole thing is it's got dialecting, so you can create a parser for whatever you want. All right, so I've lost my train of thought. So we've got a zip with okay, so now we're here and we have the bottom edge of the tetramino. And then I want to add those things together. So zip width, bottom edge tet. So zip width, zip, I call it zip W, and zip width is fine. Zip width is zip W, and then zip width X, Y, X plus Y, bottom edge tet. Nope, zip width has no value. Bit is missing its Y's argument. Yes, it is. So the bottom edge of tet with this, what I call it, the drop zone. Length of the drop zone. Hmm. Oh, right. So it wasn't the length of the drop zone that I wanted. It was something else. We definitely want that, but then, oh, I see. DH is I see. DH is the thing I want. The drop zone height, EZH or something. EH, EZH. And can we say min of this? Nope. So insert min. And so we'll say insert is what if we say zip width maybe we should say zip. Zip should be the thing that like collects these two things. So zip func x's and y's, and then we'll say oh, interesting. That's kind of nice that you can do the index there. I believe that's actually correct. Zip. So let's zip these two things. There we go. If we rotate this, what happens? What is a tet? Right, because we didn't run. Just for now, I'm going to put this in the code here. Oh, maybe it doesn't. Run. Make a T, drop it, make a Z, move it a little bit, and then set. Main. It didn't run that, did it? So it's going to be this. About TV. Reload. And then TV. And then PG. No, that didn't work. What happened there? I don't think that is the right answer. First of all, that should have been a function, but why does that return 5? Anyway, this should be a func, and that's why it's not doing what I want. Why is that not? TV should be a func. I don't know why that's not working. do load learntris.red. TV is 5 still. I don't know why that's bizarre to me. Why would that be that? Surely it's a function, right? Oh, right, because you got to say this. I'm being dumb. All right, so print matrix or print the game, and then print the drop zone, right? And then I don't actually have this little function here. DZ is drop zone. And then about the all right, so what do we want to call this? Is like length of the drop zone. Min. Hey, baby Sammy.
I like this.
Mm-hmm.
You have like this one. Like this.
She has that, a little tiny thing in her hand. Mm.
Then she got one. Bye.
Mm-hmm. So we're gonna say ints. So we'll say op, say func op, and then x's, and we're gonna say zip width. I didn't need to do that. So zip width func xy. No, but it's not. It's not that. It's going to be x. So we'll say x's equals 1, 2, 3, 4, 5. Next x's. X's is still the same, but we say next x's All right, so we're going to say op x's, and we're going to say result equals x is 1. Because this doesn't handle the, this won't handle the empty case. The empty list, like what's the sum of an empty list ought to be 0, but we don't know. Maybe we start with an accumulator. Whatever. And then for x, for each x in next x's, r is r op x, and then we return r. Op, say op is get word opsim. We say get opsim. Ins has no value. Yes, it does. Yes, that's right. Ins, so we say min, say insert min of 1, 2, 86, 3, and it should be negative 55, negative 5. Oh, value 2 argument. So R is, this is X's. What is X's? R is X is 1. That should be 1. Op equals get op sim. Op sim is that symbol. All right, so R op 3. Hey there, sweetie Petey. Mm-hmm. You want to open this little candy?
I want that.
There you go. There you go. Mm-hmm. You're welcome. But this is not an op, is it, min? 3 min 5, it's not an op. Right, so this is insert, like, this is insert op. And this is insert, like f would be the same thing, but instead we say f. I guess it's also reduce. Is there a word called reduce in here already? Yes, but it's not the reduce I'm thinking of. About fold? Fold is the word I'm looking for. Is that fold? I believe so. And then R0, we'll just say R equals R0. R0 equals, or so R equals R0. For each X, R equals, and we don't even need next X's. Start with R0. X's, R equals R op X, and then R. All right, so that's what we actually want. And it's not op, it's going to be f, fx, fr and x. Near x plus y, run zip with collect. But we're running this, and then we call zip with collect. So zip with I broke zip with somehow. Yeah. So it wasn't. It was run the whole file, not run this. All right. So anyway, so now we can say so fold min. This will never be that. So fold min 0. Fold min 0. But that's because DHZ does not mean anything. DHZ is what? This is it. This is drop down. So DZ equals drop zone. So what are we calling this thing? This is like drop. There's a func. DZ equals drop zone. Is length of DZ equals drop zone. DZH, these are the heights. DZ drop zone height, yep. And then so height. So this is distance to the bottom. Distance to bottom of to next non-empty cell for each column. Okay, and then so let's do this again. I kind of have to do this here. LDZ is DZ the drop zone. Okay. DZH. DZH. And then T height is bottom edge. Bet. Bet is the bottom edge of tet. Okay. And the idea is that this should be able to fall 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Which is the middle, and it's the middle one. So we want to say, let's say DZH minus bet, but we can't. So we have to say zip with, I'm going to say zip O, zip op, and try and get this thing. So zip op is going to be what? Zip op is like zip with, but for an operator. Yes, my baby.
I have
What you got?
a candy.
Oh, a candy. You can eat that candy. Instead of wrap, we're going to say X op. This, and we're going to say op sim. I'm going to say op. We will say op equals get op sim. Is that right? Now we keep all that for each other because that's a little crazy. So let's just, we're going to collect something for each x and x's. Keep x op and then y's of index x's. Yeah, that's right. Okay. And we don't need that anymore. I think we can rewrite this one as well. This would be collect for each x x's. Yes. Keep fx y. Yes, that's exactly. Okay. And there we go. They're basically exactly the same, except one uses an op and one uses a function. All right, so we don't know what that is. There we go. Except DZH is 16 and bet is 2. Why is it adding 1 to it? That's right. When we do minus, 10, 20, 30, 1, 2, 3. Yeah, it's subtracting 1 from all of them. This actually did not work. For each x hello, select for each x hello, x's index x's, keep index x's. Ah. And we said 2 of them. All right, so we really do need the I plus 1. So let's see if there's any other functions like that in red. But I have my red. I want enumerate from Python, right? I think repeat is what is the one that has the counter in it. Mm-hmm. All right, so this, I was led astray here by this. This actually does not work. How about we say for enum, for enum, and I would be 1. Or we're going to say art for I equals I plus 1. I'm not going to mess with this right now. Because we can't see what it looks like. I'm going to say f name. I say word. Word. No, f has no bad func. F is func, and we say f cat. It does quote it. And that means we don't have to say op sim either. We can just say op. think we can say this. Insert plus across 1, 2, 3, 4. Yeah, 10. All right, I like that. The quotes it. But for enum, so what do we want to say? We set for so some word. How do we do an assignment on that word? Assign set referred to. Okay. Word ix. So it's going to be x and I in x's. And then a block. So we would say for each x is I equals I plus 1, do block. Is 4ix or something like that for each. I don't know. Just for each with an I. For each with an index. How about that? All right, so for each ix, 1, 2, 3. All right, so for each x, I print x print xy and x print y. What's your trouble, baby? Y has no value. Ajo, see me, come here. You okay, Simi? What's wrong? I gotta go see what's wrong with the baby. Get does not allow integer for its word argument. See me, Jimmy? That's right. And then if we say for x and ix, x is an ix. Right. If we say it for I and x, you're gonna screw it up? I don't know. Can't tell. I don't think it does. For each, oh, we want to say print AA and print BB. That's right. Amy Ajo. I'm gonna rename these to like ISIM and oh. For each XX in X's set, we can even do it like that. X val in X's set xsim to x val. Set xsim to x val. Set isim to get isim plus 1. We don't even need this. And then do the block. I think that's right. Let's copy all this. I do need to go. For each ix, hello. So we're going to say each x, I, and hello, print I. Plus does not allow word for it. Right, so. Oh, so there's like some precedence there. And then print x. That works. Okay. So for each ix, all right, all of this was to say zip op plus bet, or but zip op minus bet dzh. So let's copy all this in here. It's actually this. Operator is missing its argument because zip op did not take a quote. And just paste all that stuff again. Cannot compare 0 with negative 22 to negative 22. And so min, first of all, bet. All right, first of all, we have to run that thing. So let's run TV. and then run this all stuff again. Say bet is this, and DZH is this. I've lost track of what I'm doing here. I just know that. So now I say zip op minus DZH and bet. All right, we're still doing this index thing. All right, so now, right, the whole point was to rewrite this thing. So if we say zip op is going to be a func takes a quoted op x's and y's. Op is get op, and then for each ix, xi x's keep x op ys I. And now subtraction should work correctly. Zip op bet. Oh, keep has no value. I'm going to say collect here. Right. So we're going to go the other way. DZH minus bet. 16, 14, 15. So DZH and bet. That's actually right. So I was waiting for that 14 to show up. And I realize now that, like, I've been keeping something in my head that other people have probably lost, because I kind of keep losing it too. This is not very hard to follow, very easy to follow anymore. Anyway, so now we know, so fold DZH minus fold. I didn't give it a 0. Fold F, there we go. DZH bet. Oh, but we want like infinity. 0 divided by 0? No. Infinity. Well, I'm going to start with like big number. Do better infinity. All right, RL, break it, TV, and then drop. Fold, 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 min. I gotta say min here. I gotta say that I used the colon here. Drop a 15. That doesn't seem right. Seems almost right. Zip op minus DZH and bet. DZH bet. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. DZH bet. What happened here? I got the first one again. Zip op. Did I not save the definition of zip op? Yes, I did not save the definition of zip op. And this is also wrong. Op equals get op and then collect this, but this needs to also be answer here, and this is keep f of x and y's. Reload and then drop 22, right? But TV and then drop 14. Okay, so P, so run P, and then what if we say ty, right? Ty is equal to ty plus drop. And then run P again, and it's perfect. I did it. Okay. Okay, so V. So first of all, Ty is going to be Ty plus drop and then stamp. And I think Enco test. All 38 tests passed. So we got 7 more tests to go. This was a very complicated test. This was like the hardest test. It's not. I wonder what I can do. Enco status. Yeah, status, right? I can't see what the last test I passed was. Go here. Drop collide. The drop collide was the hardest test for me. All right, I'm gonna sneak ahead and see what's in here because I just rotate a drop, test collision with blocks on the left side. Oh, I did finally do that. Oh, maybe I didn't do that. And then screen flow is like the title screen and pause menu. That was really not really in the last test. So it's really like 42 tests. I guess I'll just finish it then, since there's really just 42. I'm not going to do this test and pause thing. That was a start of something that never really happened, right? Well, we'll see how. I might just go. And we'll get rid of this TV thing. I do wonder if I'm like doing this in like idiomatic red, because I've added all these little like helper functions that make it not, like these seem to be like primitive things to me that should be everywhere. And if they're not there, then that means that people who use red normally like do things differently, I guess. So what would we say about it? I'm not going to talk about it. I'm just going to say this is implement the hard drop. All right, Tenko next. Same situation. I think this just works. Okay. So we have an issue here. Here are draped. Off to the left side a bit, then spawned a Z and manually moved it down next to the fallen blocks. The command should have no effect. Oh, this is collision detection sideways. It's the same kind of thing. I just don't feel like doing this right now. I'm ready to wrap it up, and people are at home, and it's already a 4-hour stream, and I'm gonna just wrap this up. But it's the same logic. So basically, well, it's not quite the same logic, but you know, we gotta do very similar things. So I bet if I rotate this, I can treat it as a drop. If I rotate the well and the piece, I can treat it like a drop. The primitives are all there, and then probably going to do the same thing. So basically, this is just saying you can't slide to the left because collision detection there. I don't think there is any collision detection for the side of the well. Probably, you know, consider breaking drop.collide down. All right, I'm gonna stop this here. And you know, thanks for watching. I really appreciate it if you watch this one, because I will definitely make this into a shorter video somehow in the future. There will be a shorter version of this. I might like redo it knowing what I know now. I don't know, like I kind of want to preserve the mistakes and false starts and whatnot that I made, but I want it to be presentable too. But yeah, so I'm going to stop rambling, and